FastAPI is a modern and efficient web framework for building APIs with Python. It's designed for developers who want to create web applications quickly and functionally, all without sacrificing performance. Today, we'll dive into some of the compelling features of FastAPI that really make it a top choice for API development. So far, we've learned that FastAPI is a high-performance framework that puts a strong emphasis on speed, ease of use, and asynchronous capabilities. We've also explored its key features, like automatic data validation using Pydantic, which really simplifies data handling. Oh, and don't forget about those interactive API documentation tools. It's like having a built-in manual. Now we've touched on the significance of dependency injection, which helps in managing components efficiently, and the crucial security mechanisms like API key authentication that ensure your APIs are safe and secure. As we move forward, let's continue to leverage FastAPI's capabilities for efficient API development and tap into the community resources that will enhance our learning experience even further. The displayed figure, titled Key Features of FastAPI, is a vertical bar chart that quantifies 5 principal attributes of the framework: speed, automatic validation, asynchronous capabilities, dependency injection, and documentation. The chart clearly shows the numeric values above each column, making it easy to grasp at a glance that documentation tops the chart with a score of 95, followed closely by speed at 90. Asynchronous capabilities rank at 85, while automatic validation is at 80. Now, you might notice that dependency injection, though still solid, comes in last at 75. So what does all this tell us? Well, it emphasizes that both documentation and runtime performance are standout features of FastAPI. This framework shines in providing excellent asynchronous support and robust automatic validation as well. While dependency injection is certainly commendable, it just doesn't quite reach the same level of emphasis compared to the others. All in all, this chart illustrates that FastAPI consistently maintains a high standard across essential API concerns, with a particular highlight on documentation and speed, important takeaways for developers who prioritize discoverability and performance in API design. Now let's take a look at how we can implement a simple user creation endpoint using FastAPI and Pydantic. We start by importing the necessary components, specifically FastAPI for creating our web application and base model from Pydantic, which helps us define our data model. So first things first, we create an instance of FastAPI. This instance serves as our application. Next up, we define a user class that inherits from base model. This class is crucial because it specifies the structure of the user data we're expecting. It includes an integer field for ID, a string field for name, and another string field for email. This model plays a key role, ensuring that any incoming data for user creation strictly adheres to this specified format. Now moving on, we set up an endpoint for creating users by defining a function called createUser. This function takes a parameter of type user, which allows FastAPI to automatically validate the request's body against our user model. If the incoming data is valid, the function returns a dictionary containing the user's details. However, if validation fails, FastAPI steps in to handle the error and respond accordingly, indicating what went wrong. This process beautifully highlights how FastAPI simplifies data validation and ensures data integrity in API development. Now let's dive into implementing FastAPI's interactive API documentation feature using the provided code. First up, we need to import FastAPI and Pydantic's base model, which are crucial for data validation. With our FastAPI instance ready to go, let's define a user class that extends from base model. Here, we'll list the attributes our user objects will have: an integer ID, a string name, and another string for email. Moving on, we'll set up a post endpoint at users and create an asynchronous function called createUser, which takes a user object as input. This setup allows FastAPI to automatically validate incoming requests, making sure they have all the necessary fields and that the data types match our model. If everything checks out, this function will return a JSON response containing the user's ID, name, and email. It's a neat and efficient way to build robust APIs by automating validation and enhancing user interaction. Plus, it gives developers the ability to test requests right through the auto-generated documentation available at Docs. So with this straightforward approach, we can see how FastAPI simplifies user input handling while generating useful documentation that's great for both development and testing.
Now, let's see how we can implement asynchronous data fetching in FastAPI using Python's async and await keywords. In the example we're working with, we'd start by importing the necessary modules, then create an instance of our FastAPI application. So, let's dive in. We define an asynchronous function called fetchUserData, which basically simulates fetching user data from a database. To illustrate the concept of I/O-bound operations, we utilize await asynchronous.sleep too. This creates a non-blocking delay, mimicking the time it typically takes for a database call to complete. Next, we define an asynchronous endpoint, readUser, which accepts a user ID as a path parameter. Within this endpoint, we call our fetchUserData function, allowing FastAPI to manage other incoming requests without having to wait idly while the user data gets fetched. Now, once our data is ready, it's returned immediately, showcasing FastAPI's efficiency in handling several requests at once. By embracing asynchronous programming, our application remains responsive, which is, a crucial aspect for developing high-performance web applications.
Now let's see how we can implement dependency injection in our FastAPI application to efficiently handle current user information. We start by importing the necessary components from FastAPI, and then we instantiate our application using FastAPI. Next, we define a function named getCurrentUser, which serves as a dependency that returns the current user's data. For demonstration purposes, this function simply returns a placeholder dictionary containing a user ID and name. This modularity is really beneficial, as it allows us to keep our user fetching logic separate from our endpoints, which ultimately improves code reusability. Now, we'll create a route for the user's me endpoint by defining an asynchronous function called readCurrentUser. Here, we leverage FastAPI's depends feature to declare the getCurrentUser function as a dependency. When this endpoint is accessed, FastAPI automatically invokes getCurrentUser and passes its return value to the currentUser parameter in the readCurrentUser function. This streamlined approach not only enhances the maintainability of our code, but also simplifies testing and modification of user-related logic independently, which, I must say, is a significant advantage of using dependency injection. Now let's implement API key authentication, which is a crucial security feature in FastAPI. In our code, we start by initializing a FastAPI application, and here's the important part. We're going to define a secret API key that will be used for authentication. The API key auth function is created to validate the API key provided by the user against our predefined secret. Now, if the key doesn't match, the function raises an HTTP exception with a 401 status code, which simply means that the request is unauthorized. Next, we set up an endpoint called secureData/. This endpoint uses FastAPI's depends to incorporate the API key auth function as a dependency, ensuring that any request to this endpoint must include a valid API key. If the correct API key is provided, users will receive a JSON response containing a message indicating that they've accessed protected data. It's a straightforward approach for securing your API, and believe me, it's essential for applications that handle sensitive information, as it prevents unauthorized access and significantly enhances the overall security of your API. This foundational security practice is vital for maintaining user trust and application integrity. Now let's implement the integration of FastAPI with a SQLite database using SQL Alchemy. First up, we need to install the required dependencies for SQL Alchemy and SQLite. This step is essential as it enables us to connect to and interact with our SQLite database. Next, we'll define the database connection URL. Then, we create an engine that interacts with the database. The session local instance is really useful here, as it allows us to manage our database sessions, which makes handling transactions with the database a breeze. Now, let's declare a base class for our database models using declarative base. This sets us up nicely for the next part. In our implementation, we're going to define a user class that represents the user's table in our database. This class specifies its structure, including fields for ID, name, and email, complete with their respective data types and attributes, such as setting them to be indexed or unique. Once the model is set up, creating the table in the database is straightforward. We simply call base metadata, create all bind equals engine. Now, with our FastAPI application instance created, let's define an asynchronous endpoint that allows us to add new users. The createUser function will accept user details, initialize a new user object, and then commit that to the database. This efficient approach to database interaction showcases FastAPI's seamless integration with SQL Alchemy, giving you the tools to build robust web applications. As we wrap up our discussion today, it's vital to highlight the incredible community and resources available for FastAPI developers. FastAPI boasts a vibrant community. Seriously, it's like a goldmine of information. With extensive documentation, tutorials, and forums, you'll find plenty of places to seek help or get inspired. Now, let's talk about the official FastAPI documentation. It's a fantastic resource. It covers everything from installation all the way to advanced usage. Here's a quick example of how to navigate it. Just visit https://fastapi.com and you'll see sections neatly categorized into tutorial, deployment, and advanced. Each section is meticulously structured, offering code snippets, examples, and explainers. And guess what? The community actively contributes to this documentation, enriching the learning experience and making it super easy for newcomers to dive into the FastAPI world. By leveraging FastAPI's numerous features, you can build robust, high-performance APIs that cater not only to your needs, but also to those of your users. Its ease of use, combined with powerful capabilities, makes it an excellent choice for any developer venturing into API development with Python. And remember, it's crucial to continuously explore community resources and experiment with your own projects to really solidify your understanding. So let's summarize what we've covered. We delved into the key features of FastAPI, including automatic data validation, interactive documentation, asynchronous capabilities, dependency injection, security mechanisms, SQL Alchemy integration, and those invaluable community resources. By harnessing these features, you'll be well on your way to becoming proficient in building scalable and efficient APIs. So keep coding, and until next time, happy coding.